So here in this video, I will be demonstrating my conversions from simple and or not circuits into circuits composed of only NAND or NOR gates. First, I will be demonstrating a NAND circuit, and here is my equation. I have Q equals, in the first set of parentheses, I have A and complement B and C, ORed with C and complement of A. I have complement of A and complement of C, ORed with C, and simply just B at the end. Everything is all ANDed together. So here's the unsimplified circuit here. I have these two AND gates. They get sent into this OR gate. So in the first AND gate, I have A and complement B and standard C, as we can see here. And I have C and complement of A. Here we are, and they are ORed together and sent off into the AND gate. And I have a complement of A and a complement of B. Here we are. It's so easy to get lost in all these wires. Here we are. You can see I took from... Actually, I believe that wiring may be incorrect. So let me just go ahead and change this up. Okay, and that is complement of B, and I'll need to change that in my other circuits as well. And we have just a simple C in that OR gate where they're ORed together, and everything is ANDed at the end. So here I substituted using the NAND gates. The OR gate turns into an AND with two NOT gates before it, and our AND gates have a little bubble representing a complement with a NOT gate in front. So let me go ahead and change this right here real quick before I continue on any further. Apologies. Okay, there we are. So when simplifying from the substituted circuit, you'll need to cancel out any double NOT gates. So you can see here I have a double right here, so I went ahead and canceled that out. And I have one here, cancel that out, and one down over here, canceled out. Okay, and here is the reduced version of my circuits. And as you can see, everything would be complemented at the end because of this NOT gates at the end connected to the AND gate or NAND gate. We can see here that this is I have A and complement of B and C. It is complemented, sent off into this now AND gate, which used to be my OR gate, and that is with my now complemented C and complement of A. It turns into just a similar equation, a bit more complicated, and to represent just as an extra little proof that is correct, I went ahead and I replaced I apologize. I went ahead and I replaced those now AND gates with inverted OR gates. So we can see here that everything would be complemented, sent off here. It would be canceled out. The complement cancels out since it's complemented again with this little bubble. Same thing for C and complement of A. Sent off. Everything's canceled, but then it gets complemented again. So it's similar to what I had drawn originally. And this here is my all NOR circuit. So here's my equation. I have S equals parentheses X and Y and Z ORed with parentheses complement of x and standard y and complement of z, ORed with y and z. So here's my unsimplified circuit. I have x, y, and z, standard of course, standard x, standard y, and standard z. That is sent off to the OR gate to OR it all together. Next, I have complement of x. Here I have x broken up into its own separate branch, which is complemented. Standard y, just brought that over, uncomplemented of course. And I have complement of z broken off into its own branch, in which it is complemented and brought here into the AND gate, sent off into the OR gate, and just standard y and z. There we are. So next I substitute everything with its NOR gates. So all the AND gates turn into ORs, and they all include a NOT gate as its input, and there's a little bubble that complements it here at the end, and the OR gate stays as an OR. You add a little bubble to complement, as well as a NOT gate after it. Very similar to, of course, it's similar to the NAND gates, of course, because it's all OR gates, or not OR gates. And from here, you reduce double NOT gates. So we can see over here, everything here is fine. Nothing is doubled. So, but here, we can see we have two doubles. Y and Z are fine, of course. So I have two NOT gates here, so I will cancel this out. And I have a double with Z, canceled out as well. And here is the whoops, ignore that, that is what I just did up here. And here it is finally in its reduced form. So just to kind of prove it, I'll go and I'll do a walkthrough. So everything here in X, Y, and Z, it is all complemented. And the bubble here cancels that complement out, so it's just standard X, Y, and Z again, sent into the NOR gate. Everything's complemented again, but then it's canceled out by this NOT gate. Same thing for complement of X, Y, and complement of Z. X, it comes in as standard since it got canceled out, but it is complemented by the bubble. Same thing for Z, they are complemented by the bubble. But then here in the NOR gate, it cancels out, but then it gets complemented again. Y goes in complemented, comes out uncomplemented, complemented again, and then uncomplemented by the NOT gate. Y and Z both go in complemented, come out uncomplemented, go into the final gate, coming out complemented, which then cancels out.